Jonathan here, and most of our talks so far have been doom and gloom, and this may be doom and gloom too, but uh, but it's far away, and this one is so abstract that even I can't get worried about it. But if the trick is the universe, let's just consider it as a puzzle, not as ultimate quest for truth, but just knowing what we know. How does it fit all together? The universe began with a big bang. Um, that's what they say, and that theory accounts for a lot of evidence, but it's to a naive mind like mine, that sounds like magic. I'm um, here. Oh, there we go. There's a magician. That's tarot card. Yeah, sounds like magic. I don't like magic. Uh, it gets worse. Shortly after the Big Bang, the universe enlarged at more than the speed of light, but special relativity, uh, you know, Einstein's E equals mc squared, um, uh, says you cannot exceed the speed of light. Don't worry about proving the theory. It's really just algebra, plain old algebra with what were at the time already well proven scientific laws. Um, uh, Einstein was kind enough to write out an explanation, actually a proof, suitable for the kind of the general public, um, about just about for me. Okay, I took calculus in high school and a couple of semesters in college and actually passed, which left me with less confidence in math than I would have expected. Reading Einstein was like listening to somebody talking in French or German. You can pick up a few words, follow the gist maybe, um, but at least it's better than trying to follow Chinese or Japanese. Um, so, um, picked my way through the Einstein's proof of his special theory of relativity. Um, I recognized a few things, the Lorentz contraction and Maxwell's field equations. And at the end of the story, seemed to me the proof was watertight. I believe that you can't exceed the speed of light. But it wasn't the matter in the universe that was exceeding the speed of light. Space itself was expanding. Um, and that's not much help for the naive mind. At the beginning, everything was photons or other primary particles, quarks and stuff that's not going to lie around without reaction. The photons will bounce off things. But everything was. The heat initially was, they say, so intense that everything just was reduced to its primary particles. And in order to turn into normal matter, those particles have to interact with normal matter. They have to be, quote, observed, or at least they have to hit ordinary matter in order themselves to be ordinary matter, and there wasn't any ordinary matter to interact with. Now then, recently somebody noticed enough of the fact that this is a problem to say, oh, well, extraordinary matter is spontaneously turning into normal matter all the time, but not enough for you to notice. Really, that doesn't sound like it's evidence-based to me. So there had to be a big observation. Something had to enter this soup of stuff and, as it were, started crystallizing. It sounds sort of biblical, and God said, "Let there be light," and there was light, and God saw the light that it was good. Wait, the big observation. It's in Scripture, it's not in physics, even though it is absolutely necessary in physics. Doesn't prove anything, but the fact that it's scriptural does mean a person should be forgiven for being prudent, careful, as it were. Okay, after the big observation, the laws of nature were established and they turned out to be just right for life. Mm-hmm. The universe appears to have continued to expand at a moderate rate. Most of the matter in the universe, most is normal matter with almost no antimatter. That's a jolly good thing. Since the collision of an antimatter star with a matter star would throw out a whole lot of energy, disrupting things, well, throughout that galaxy anyway. Jolly good is another way of saying it. Sounds like magic. Why do we have all regular matter and essentially no antimatter? Um, Now then, if you have random fluctuations in the initial energy in the universe, those fluctuations, there were fluctuations, and they can still be seen, but what you see really isn't big enough. The fluctuations should have been bigger. What we see should be bigger, and what they say is that the initial expansion, the great inflationary moment, smoothed out all the wrinkles, like straightening a sheet in the bed by pulling on it. But if you pull on a sheet, generally it takes more than one tug to smooth it out. So, oh yeah, it was just one tug, and it was just exactly what was needed to bring all those massive primordial fluctuations down to a nice, uniform, smooth situation. Then there were differences in the distribution of matter that fluctuated. So now you're talking about smoothing out a sheet and a blanket all with one pull. Yeah, you see, the sounds like magic again, doesn't it? Okay, then there's life. Okay, energy comes in from, let's say, a star, uh, makes life, then the energy goes away at a lower temperature. All right, but why pause? Why not just go straight from here's what happens. Energy interacts with matter, permitting life, and then the energy radiates away. Why not just go energy, matter, energy? Weird, okay? Um, the fact that it pauses, the numbers balance, all calculations are fine, but why would it bother pausing? Why not just leap straight to where it's going anyway? Okay, if you look at a galaxy, stars moving as if there was more mass um, than the stars themselves account for. This mass is called dark matter. Now, they've recently come out and said that half the mass of the galaxy isn't in the stars after all, it's in dust clouds or something. And the article I read didn't mention dark matter, so I'm not sure, but what's been said until perhaps recently is that there's dark matter associated with the galaxies. The dark matter is kind of a halo around the galaxy, I guess. And this dark matter is something you can't see. Um, Now that if you look at distant galaxies, and yeah, of course that's dark matter. Does that sound like black magic? Yeah. If you look at distant galaxies, it looks like um, the expansion of the universe is speeding up, and that sounds like dark energy. Now that's really spooky. Besides which, if you stick more energy in it, you stick in the universe, you're sticking more mass, and you're getting more gravity. So the dark energy seems weird even by the standards of what science tells us. Okay, now anything that science can learn can be taught on a computer. Alan Turing proved that a computer cannot do abstract reasoning. Just like with Einstein's relativity, I've had a look at the proof, and it looks airtight to me. Not that I understand it all, but yeah, as he proceeds through, it just okay, right? That sounds like it's all right to me. And nobody's challenged it since Turing's day years and years ago. I certainly don't remember it well enough to tell you. And now this inability of a computer to do abstract reasoning, he'd already proved that if you can build a general purpose computer, and his computer depended on having a paper tape on which things could be written and rewritten according to a set of rules. They could also be written on a paper tape, and this would go zinging back and forth. And I'm sure it was from his code cracking days, and these paper tapes running all over the lab carrying routines that had to be repeated again and again to try to break a code. And every now and then the paper would explode and you get confetti. I'm sure that happened. Of course, it was all top secret. Those stories don't come out. So it doesn't matter if you're looking at a massively parallel deep learning quantum computer or not. The proof still holds. A computer can't think. It can work with everything that science offers. So make an observation, create an image, do a calculation, come up with a routine of any sort. If you can write it down in a way that science can digest it, a computer can work with it just fine. So, there's a lot of money, someone said $1 billion being spent to figure out how the brain works, and how we can get to the machines being able to think, and that's wasted money. Yeah, maybe keep the people off the street, but is there anything useful to do in terms of neurophysiology and brain structure? We just pulled out a generation's worth of talent and stuck them into a dead end. The computer can't do abstract reasoning. But we do. At least Turing was able to, Einstein was able to, okay, here's some abstract reasoning. Take the number 0. What is it in Roman numerals? Haha, that's a trick. Okay, the capital I is 1, IV is 4, V is 5, VI is 6, and so forth. Yeah, if you really were hard pressed, you might say, well, V is zero, right? The number to the left is subtracted. But the Romans never did that. They had no sign for zero. Uh, a child can't understand until he's four. Um, the Mayans, they had a system of knotted strings and so forth, and they had a sign for zero, and they probably got it, they say, from the Olmecs, which had it centuries and centuries BC. Um, Western civilization formalized zero starting in India about the time Europe was entering the Dark Ages. But recent work suggests that bees, honeybees, able to learn to understand zero as being another number. It's just one digit lower than one. Bees can comprehend that. All right. So, since our ancestors split from the bees about time of the Cambrian era, that's first complex life, in the fossil record, uh, it seems hard to believe that we and the bees inherited this ability to do abstract reasoning and nothing else did. So, abstract reasoning is not an emergent phenomenon of our super large brains. No point in trying to record a human brain. If you're looking for that abstract reasoning ability, bees can do it a lot cheaper to look at a bee brain. So, abstract reasoning is a property of the universe that cannot be explained by science. Never will be. Sorry. The tools of science, reproducibility, and observation, that sort of thing, they will never give you the reason abstract reasoning occurs. Okay, so people, even animals, understand fair and unfair, maybe to different degrees, but how? Again, it is not an emergent property of the human brain because animals can understand what's proper, what's fair, not fair. So there is a moral order to the universe, which is built into the universe. It is not a property just of the human brain. As a matter of fact, the Enlightenment, and I could go on for a while about why the Enlightenment happened, where and when it did. Basically, they came up with things like, well, you remember the Bill of Rights, the Declaration of Independence. Very logical, very clear, focusing in on human rights. All right, they were just drawing on Enlightenment teaching. The 16th century, they call it the long 16th century because it's basically lasted 200 years. That was the Enlightenment. As late as the early 1800s, the Enlightenment had struck so deeply in England that they decided slavery was a bad idea. Oh, really? They undertook to eliminate it from the world. Well, they didn't get it eliminated everywhere. There's still slave markets out there, I understand. But they tried. They backed it up by quoting ancient Hebrew text, scripture, They'd find things in scripture that justified what they were doing in the Enlightenment. It wasn't scripture that taught them. Scripture had been around for centuries and centuries before people said, oh, look, and came up with Enlightenment principles. So the Enlightenment also is the Principles of enlightenment are not an emergent phenomenon of the human brain because of its size. Well, it maybe helps us deal with it, helps us manipulate the principles, but the principles themselves are embedded in the universe. It's just more on the theme of fair and unfair. Okay, um, there was no evidence for life for a long time after the Big Bang. Um, After some billions of years, the energy in the universe will be so diluted over by the expansion of space that it will be it's hard to believe that there will be life way out there. So life, no life, no life starts with no life, life, no life. All right, that's what the universe is doing, and what's the point? For that matter, why is there anything at all? Isn't there just nothing? So there are some things that look like magic, a bunch of them, and I don't like magic. If there's such a thing as magic, then nothing makes sense. And every time you say something or plan something, you have to say, "Oh, magic permitting," of course, because things that are logical and consistent and based on hard fact are going to tamper with you. Of course, they're going to tamper with you at random. But if there's magic, then that random tampering is going to be patterned, and it's going to have significant effect, and it may be more significant than the reasonable things uh, that that you can handle with your mind. So I shall beg your patience. I'll try to get rid of magic in our description of the universe. Won't be able to get rid of all of it, but I'll do the best I can. Um, so let's see how we're doing here. Um, I think it's time to put a pin in it there. I'm going to say we'll start here next talk, and we'll start trying to put together a set of principles and physical theories that, although you cannot exclude something magical, at least minimize it. Okay, well, one moment here while I find my cursor. There we go. Okay, got the cursor. So long, come back for the next installment.